Hey guys, Mr. Riz here to help you out with the 3.5 and 3.6 notes. Now 3.5 and 3.6, we're going to convert them together because we can use Desmos now. We can use the graphing calculator a whole lot easier, and so we don't need to go through 3.5 where we're making a table and doing a bunch of guessing and checking. We're going to use what we will learn in 3.6 to help us figure this out and finish off these problems. So our goal here is to take an expression here, any polynomial expression, and be able to find all the factors of that expression, meaning we can break down to what, this parenthesis times this parenthesis times this parenthesis is this expression here. So we want to go through and answer these questions. We're going to use Desmos to help us out at the beginning, but some things we should know before we even get started. So the first thing we should know here is actually, you know what we're going to do is I'm going to put this up on Desmos. Let's do that first. Let's type the equation in on Desmos. That's going to help us out. So we get 5x to the third plus 12x squared minus 29x plus 12. Oh, I realized I was doing a calculus problem. That's way crazy. Okay. We zoom in. Okay. So we get some answers here. Okay, so if we wanted to answer this first, maybe, you know what, I'll try to do this. I'll try to zoom this in here and then squeeze this over. There we go. That looks a little bit better. We could probably do all the work in that, hopefully. You guys will have to write small here. All right, so here's the deal. If we wanted to figure out how many zeros to expect. Remember, our zeros are determined by the highest degree. This is degree 3, so there should be at least 3 zeros, meaning we're going to have x equals something, and x equals something. And we would have 3 factors because each 0 is associated with a factor. And that's all from degree 3. Okay, next part. Make a table where the change of x is plus or minus 1 over q, and q is the leading coefficient. So we would normally make a table on our graphing calculator where we'd make the change of x, is equal to plus or minus 1 over, in this case, 5. And this is what we would technically do if we didn't have Desmos. So if we didn't have Desmos and we had just a regular TI-83 calculator, we'd go to our table and we'd do, okay, we'd start with every number plus or minus 1/5, which is like 0.2. And so we do like 0, and we do 0.2, and 0.4, and 0.6, and 0.8, and then then 1, and 1.2, and then 1.4. And we'd keep making these tables, and we'd be looking for numbers here that equal 0. These are called our rational zeros. Well, now that we have Desmos, we don't actually have to go through that table and search and find the rational zeros. The one thing we can do on Desmos is we can click on our x-axis line. We can find out where the rational zeros are. Now, your rational zeros are your zeros that come out to be like nice numbers. If this was like negative 4.2133758227, like it went on forever and had no pattern, comma 0, that is not a rational zero. But we have 3 of them right here. We would have -4, we have 0.6, and we have 1. And if we really wanted to right now, we can say that our zeros are x equals -4, x equals 0.6, and x equals 1. Now, how we can get our factors is by using synthetic division. Now, this problem, our first problem, actually works out super nice that we didn't have to do synthetic division for this, but we're going to go through it just to practice this here. So if -4 is a factor, that means, or is a real zero, that means x plus 4 is a factor. What that also means is we can take and divide our expression using synthetic division of -4. So we can do 5, and then 12, and then -29, and then 12. So just to prove this here, so if I divide this expression by x plus 4, or synthetically divide it by a -4, we drop down the 5. 5 times -4 is -20. Add it together, that'd be 8, or -8. times it by -4, that is a positive 32. Added together, that is 3. Added together, that would be -12, and that has a 0. So that means our equation would be x plus 4 times 5x squared minus 8x plus 3. Now we want to keep going. We want to simplify this to as many factors as we can. We can actually take this a step further. Another easy one that we could do here is x equals 1. We can change that to x minus 1, or we can synthetically divide this answer here by x equals 1. So what we're going to do here is we're going to just keep building off of our synthetic division by our next expression. So I'm going to put a 1 here. All right, so we'll drop down that 5 again. 5 times 1 is 5. Added to -8, that's -3. Add times it by 1 is -3. Added down, that's a 0 remaining. So we would not only have our x plus 4 factor, but we would also have our x minus 1 factor. And what's left over is, if that was x squared here, that drops down to x, so 5x minus 3. And in fact, that is our last factor here, our 5x minus 3. Because if we solve this problem here, we'd add the 3 over, divide by 5. 3 divided by 5 is 0.6. So our ultimate goal here in this problem is, given any polynomial, can we convert that to its factors and its zeros? So 5x cubed plus 12x squared minus 29x plus 12 is really just x plus 4 in parentheses times 5x minus 3 in parentheses times x minus 1. Now keep in mind they can go in any order, but that's those 3 parentheses all multiplied together. Okay, so this one worked out perfectly because every single zero was a rational zero. We're going to go through eventually what happens if we don't have rational zeros for all those expressions. So let's clear out the drawings here and go to the next one here. Okay, so let's start it off. How many zeros do we expect to have? If we look, we have a degree 3, so there should be 3 zeros. So it should be x equals, and x equals, and we should have 3 factors like such. Okay, now if we were going to use our table here, we'd look at a table that is plus or minus 1 divided by our leading coefficient is 1. But what we're going to do is just go to Desmos here for this next part and see where it crosses the x-axis to get our rational zeros. So type in the equation x to the 3rd power minus 5x squared plus 75x minus 125. All right, well, zoom out a little bit. Yeah, it looks like it only crosses the x-axis right there, which is at 5. So we only have 1. Unfortunately, like the last problem, we got 3 rational zeros and it was a degree 3. This problem, we only get 1 real rational zero, and that's degree 5. So we can put a 5 here, and our factor would be x minus 5. Question is, what's left over here? So to figure out what's left over, we're going to use synthetic division to simplify our expression. So we'll synthetically divide by 5. And let's see, we have a 1x cubed, a negative 15x squared, a 75, and a negative 125. All right, drop down the 1, that's 1. 1 times 5 is 5. Add it to negative 15, that's negative 10. Negative 10 times 5 is negative 50. Add that to 75, that's 25. 25 times 5 is 125. Add that up. All right, that's 0. That worked out. So our equation right now is x plus 5, or x minus 5 times 1x squared minus 10x plus 25. Okay, so the next thing we want to do is see, okay, how can we simplify this expression? We know it's x minus 5, but how can we break this part down into 2 separate parentheses? Well, there's actually 3 ways we can do this. This is just a quadratic equation. We know how to simplify a quadratic equation by factoring, by completing the square, or using the quadratic formula. So let's just rule out completing the square. That's terrible. Nobody likes that anymore. Let's double check to see if we can factor this expression here. What two numbers multiply together to give us 25, add together to get negative 10? And let's see, that would be negative 5 and negative 5. So this expression here would be an x minus 5 times x minus 5. And then we also have the x minus 5 from before. So we can break this first part down that we have here. The two leftovers are just x minus 5 again. So our zeros are just all 5, 5, and 5. So realistically, we only have one zero. The one zero is 5. We do have three factors, but they're all the same thing. And so one thing that we can talk about later on is the duplicity of these factors, or the duplicity of these zeros. How often are these zeros duplicated? In this problem, this is a degree 3. We only have 1, 0, 5, and it's duplicated 3 times. So kind of a weird problem, but interesting things that can happen. Okay, so we talked about that. Let's move on to the next problem here. All right, 2x to the 4th plus 11x cubed. Okay, so let's put that in Desmos here while we got it. 2x to the 4th plus 11x to the 3rd minus 5x squared minus 43x plus 35. Okay. So going through this, looking at this, we would have how many zeros? We should have 4. And so that means we have x equals, x equals, x equals, and x equals, because there's 4 of them, and we would have 4 parentheses left over. All right, so in our table, we would technically do plus or minus 1/2. So we're going to be looking at like our real zeros that are either 0.5 or 0, like, you know, anything that you can divide by half. And we're going to use our calculator here to help us figure those out quickly. So if I go ahead and click on this, we have 3 spots where it crosses the x-axis. Is that it? Oh, no, there's one more. All right, let's, we got negative 5, we got negative 2.76, 1, and 1.266. Okay. So the one thing about irrational zeros are only going to be factors of plus or minus 1/2. Negative 2.76 is not like negative 2.5 or negative 2 or negative 3 or negative 3.5. It doesn't end with a 0.5 like the 1/2 would tell us to do. So that is not a rational zero. So that means the only rational zero that we have right now is negative 5 and positive 1. These factors, even though they are zeros, are just not going to be rational. We'll talk about what that means when we get to it. So that means x equals negative 5 is an answer, and x equals 1. So we got x plus 5 and x minus 1. So let's use synthetic division here to go through and make our life easier. Let's synthetically divide by negative 5, 2, 11, negative 5, negative 43, and 35. All right, drop down the 2 is 2. 2 times negative 5 is negative 10. Added together, that's 1. 1 times negative 5 is negative 5. Added together, it's negative 10. Negative 10 times negative 5 is a positive 50. Added together, that's 7. 7 times negative 5 is negative 35. And that's 0. That makes us happy. All right, well, we already have another one. We have 1 here, so let's synthetically divide this by 1 and see what's left over. So drop down the 2. 2 times 1 is 2. Added together, that's 3. 3 times 1 is 3. Added together, that's negative 7. Negative 7 times 1 is negative 7. Drop it down, that's a 0. So when we divided by x plus 5 and then divided by our x minus 1, we get left over. Let's see, this was x to the 4th, and we dropped it down 2 spots. So it'd be 2x squared plus 3x minus 7. So we got to figure out, okay, how does that break down to 2 parentheses? So remember, our goal, if we can't break it down to 2 parentheses, is we see, okay, can we factor this? What 2 numbers multiply together to give us negative 14, add together to get 3? That's just not going to work out. So the other thing we can do is do the quadratic formula to figure out this answer here. So we'd get x equals negative b plus or minus the square root of b squared minus 4 times a is 2 times c is negative 7 all over 2 times a. Okay, so we would get x equals negative 3 plus or minus the square root of 9. All right, this would be negative 8 times negative 7. That'd be positive 56 all over 4. And we get negative 3 plus or minus the square root of 65 over 4. The 65 breakdown, that's 5 and 13. No, so that doesn't break down. So really, we have two answers. We get x equals negative 3 plus radical 65 over 4. And the other one is negative 3 minus radical 65 over 4. And you know, if we want to double check, it's kind of hard to see, but I'm going to just type one of those answers on Desmos. Negative 3 plus, how do I get the square root here? Square root 65. And we're going to divide this all by 4. I get 1.265. And if we remember, it wasn't that exactly what that is right there. All right. So, and then how do we write this? All we need to do to write that as a factor here is just change the symbol in front. So if it's x minus, we're going to put x plus 3 plus radical 65 over 4. And then actually we probably should multiply, but yeah, x plus 3 minus radical 65 over 4. Yeah, actually that's not right, but it's good enough that we could have done there. So the big thing here, what I would be checking on a test or an assessment here, did you find these two correctly? Then after synthetically dividing here, did you do the right steps when you did quadratic equation to find the other two? All right, we got one more to go. So actually we got a couple more to go, but okay, this next problem here is going over the last type of problem. So we had problems that were all super nice, all numbers that came out perfectly. Then we had one where we had some duplicates. Then we had a problem where we had answers that were like numbers, decimals, but they were like, you know, rational square roots. And the last thing that we could have here is this problem. So let's type it in on Desmos while we got it. X to the third minus 11x squared plus 41x minus 51. Okay, we got something that looks like that. Okay, so if we look at this problem here, this is a degree 3. And so we're going to have 3 zeros. And 3 factors. All right, so our rational zeros are going to be plus or minus 1 over 1. So it's just going to be whole numbers that we're going to be looking for. So we're going to click on our mouse and just hopefully cross your fingers that this is a whole number. It is 3. So that means one of our zeros is 3, and we'd have an x minus 3 as a factor. So to figure out the other two, we need to take our problem and synthetically divide that by 3. So we have 1x cubed, negative 11x squared, 41x, and negative 51. Drop down the 1 is 1. 1 times 3 is 3. Add it to negative 11, that's negative 8. Negative 8 times 3 is negative 24. Yeah. Add that to 41, that is a positive 17. Times that by 3, that'd be a positive 51, which works out perfectly. All right, so we would get a problem here. This would be an x minus 3 times 1x squared minus 8x plus 17. So the next question is, okay, how can we turn this into two things multiplied together? Well, we try to factor it. What two numbers multiplied give you 17, add to get negative 18, doesn't work out. So we got to do the quadratic formula. X equals negative b, so that'd be a positive 8 plus or minus the square root of 8 squared 64 minus 4 times a is 1 times c is 17 all over 2 times 1. let's see, it'd be 8 plus or minus the square root of 64 minus, all right, 4 times 17 will be 40 plus 28 would be 68 over 2. 8 plus or minus the square root. All right, 64 minus 68 is -4. Ooh, okay, so we haven't seen this yet. If we take the square root of -4, the square root of 4 is 2, but it's negative, so 2i over 2. So our answer is, we can divide those both by 2. 4 plus or minus I. So we will have one factor that is 4 plus I, and we have another factor of 4 minus I. So we can also have imaginary factors that exist. And this is starting to be why imaginary numbers are important, because they do affect our graph, but not in a area that we can see. So our factors would be x minus 4 plus I, and this one over here would be x minus 4 minus I. The one thing that we could always do is, if we wanted to do the crazy distribution here, we would get that answer. Okay, so pretty much now I can give you guys a large problem of any polynomials here, and we would be able to figure them out. But we can't do every single one, and that's just how it will go. We just won't be able to do all of them until much later, in life. So a couple problems to watch out for are ones that we want to be able to do. So if we look at this first problem here, 3x to the 4th power minus 2x squared plus 6x minus 10. All right, so we would know here, we try to see like where does this cross, and we got 2 spots where it does cross the x-axis, even though we should potentially have up to 4. We got 2 of them here. But remember, if this one here, we look at rational zeros, so plus or minus 1/3. So we'll be looking for like 0.0 or 0.333 or 0.66. Both of our answers are neither one of those. So we would have no rational zeros to begin with. If we look at the next problem here, can I slide this over? It's not letting me. Oh, hey yo, move that quite a bit. Let's look up x to the 4th minus 7x to the 3rd minus 4x squared plus x minus 49. All right, so same thing, rational zeros, plus or minus 1, nothing. We get no rational zeros. So we got to make sure that our rational zeros exist for us to break down. So if you ever get one that doesn't work out, that means you typed it in wrong, because I'm going to make sure that all of these come out nice. All right, guys, so what you guys will do for the next 2 days is you guys will work on your problems here. And then what you also do in class, you'll have an in-class assignment to get done on that day. So best of luck with this, guys. Hopefully you have a good time. And if you have any questions, just ask. Let me know if you need some help. We're working on this for 3 days. It takes a while. All right, good luck.